Hey everybody, how you doing? Glad to have you here. My name is Keith Barker, and we just had a quiz on Sunday at 11 a.m. Pacific time. And what I did is I took that recording and then I edited it down. So if you're watching the recording of this, it's a lot quicker. Here's a quick breakdown of how it'll run. I'll introduce a question, and then I'll give you in the corner of the screen a countdown of 5, 4, 3, 2, 1, and boom! And then the actual answer will appear, and then any explanations I include. The benefit of doing that is that as you're watching this video, when you see me doing that countdown, 5, 4, 3, 2, 1, pause it, and that'll give you as much time as you need to think about the answer, what it is, why it is, and then you can click on resume and see the answer. So without further ado, enjoy this recording of the live quiz. A Kahoot by Keith Barker, the OG of IT. I'm glad you're here. This is the 2020 edition. I'm super excited. 3, 2, 1. These are random order, randomized questions. Question 1 of 9. When does static NAT show as a translation? Let's talk about this just for a moment. If we do a static NAT translation, static is simply meaning we hard code it. IP NAT inside, source, static, and then we can specify the internal address and then the outside or reachable address. And boom, once we do that, press enter, that's going to show up like this. Now, that doesn't mean that this entry is a static NAT, because this could have been done dynamically with NAT as well. But if we do a static NAT and press enter, it doesn't matter if any traffic has gone through the router or not between the inside and outside interface. That static translation will show up. Now, on top of that, if this was a static translation we created, then as we have traffic going over those two interfaces, then all these individual details will show up about the translations. So the key is this, and this will help you for other questions coming up in this quiz, is that for NAT to work, so here's our router, router 1, here's the inside interface and outside interface. And the way we label those is IP NAT inside on this interface and IP NAT outside on that interface. And with dynamic NAT, when Bob the user sends traffic to the router, and if that router is making a routing decision, people forget that. It's like the decision to forward traffic always comes first, and then we're going to implement like policies and rules and NAT. And so if the router says, oh, I need to forward this packet going this way to the next top router, it would then say, oh, it's coming in on this inbound interface, it's going out on the outbound interface. I need to go ahead and based on the rules, I need to do translations. So if we do a static NAT, that entry will show up the moment we press enter, even before packets show up from the user. And then when Bob's traffic shows up, if his address is .51, then looks like he's going to a DNS server. It looks like Bob is going to a web server with HTTPS with port 443. It also looks like Bob's going to another server at this guy's address at .443. And usually we're going to see a lot of DNS because you need to figure out where you're going based on name to IP address before translation starts. So that's a warm-up. I'm happy that you're all here. It's great to have you. And this, what I just shared with you, is probably good for a few more questions in this quiz. And in the blueprint, let me open it up real quick. Also, let me just say hi to you, make sure my camera's working. There it is. IP services, section module 4 of the CCNA blueprint says, I'll use my best voice for this. Configure and verify inside source NAT using static and pools. Great. So that's what we're all about in this quiz. Everything's going to be related to those topics. Here is question 2 of 9. What is true based on this specific output? All right, what is true based on this output? I'm curious. Let me just think with you through this output. Now, I know that inside local is like the real IP addresses on our clients. So if visualization helps, great. There's R1. There's the inside from a NAT perspective and outside. And again, the way we train a router, like what's in, what's out, is we tell it. We go to the interface and say IP NAT inside, IP NAT outside. We set up some rules. And then if traffic is sent across, it enforces those rules, whether it's static translations that are in place or dynamic. So I've got PC1 at 10.51, that's the last 2 octets. PC2 at 20.52. Okay, so these bad boys, I'm assuming a 24-bit mask, but either way, they're different devices, and that's their real addresses. Now, as they get translated, These are the addresses with source address translation that we're translating into. And we are translating into, let's see, 51 gets 43 and 52 gets 43. It looks like a pat to me. Port address translation, also affectionately called overload of a single IP address, is when you take multiple internal addresses and you do, you map them to one address. And then if you need to, the NAT device can play with the port numbers to track them all and keep them all unique and separate. So I think pat is definitely the answer. So that's here. Oh yeah, and the IP address on the internal client is not the 192.168, so that's not correct. The difference between source NAT and destination NAT is on the initial flow of traffic. So on the initial flow of traffic, let's say PC1's going out to the internet. On the initial flow of traffic, which IP address is being swapped out? Are we swapping out the source address on that initial flow or the destination? And all CCNA wants you to know about is source NAT. So that's all we're doing here. So anything with the word destination in any of these quiz questions is not going to be accurate. Now, just as a heads up, why? Keith, why would we ever use destination NAT? And the answer is, let's say we have router 2, not to be confused with router 1, or this is also could be a firewall. And then we have a DMZ with our server, and the server has a private address of 10.1.1.1, for example. And on the internet, we have a DNS record of 23.1.2.3. So Bob on the internet is going to go ahead and hit that, like do name resolution, like what is www.myfavoritesite.com gets resolved to this address, which is forwarded to our router, at which time, if we have a destination NAT rule in place, it can say, oh, traffic going to 23.123 really should be going to 10.1.1.1. It will swap out on that initial flow. It will swap out that destination address for our server's internal address. That's the key. And that would be an example of destination NAT. Think of the initial flow. The other thing that got me is that NAT does, let me pull the mic over. NAT does a couple things. It does translation on the way out, like for source NAT, swapping out Bob's or the user on the internal network's his source IP address. But on the return packet, we untranslate it. So with NAT or PAT, we're doing translation initially, and then we're untranslating the traffic for the return path. With CCNA, we're going to focus on just source NAT. You don't need to worry about destination NAT for CCNA, but I thought it'd be handy to have you know exactly what that is. Question 3 of 9, dynamic NAT isn't working. What needs to be corrected? All right, the access list is wrong. I'm interested. Let's take a look at this together. In fact, you know what? Let's just do this. Let's do this live. I was starting a few minutes late. I booted up a rack of virtualized devices, and this is one of them. So I just want to check out with you, if you've got a moment. Let's just make sure that this reflects what this question was all about. Let's do a show, run, pipe, include, and let's include anything that has the word NAT in it. So that's every row of output. If it has the 3 characters NAT, in that case, it'll show up. So I've got a net mask there. So tunnel this. Okay, so the 2 interfaces, gig 0/3 is IPNet inside, and 0/2 is IPNet outside. We could do a show run of those interfaces to verify that. That looks okay. Then we have our static NAT rule, IPNet inside source static. The inside address 10.1.20.52, we're going to map to 192.168.1.172. That looks good. Also, I want to let you guys know that I used RFC 1918 addresses on the outside interface because I wanted to drive home the point of reading an output and how it works, regardless of what addresses are being used. Because a lot of times we see examples, at least for me, I'll see an example and it'll have like a publicly routable address. I'll think, oh yeah, that's the outside address. It's like, well, you're just looking at an address based on the category, but if you want to really troubleshoot or work with NAT, you probably ought to understand where those addresses fit in the output. So some of that is built into this as well. All right, so that looks okay. And then we've got IPNet inside source list 1, pool, our pool. So there's the range, 173 through 180. And so is this not working? If we bring up a client, I've got a client out here. Here we go. So it's not going to fly because NAT's not working. So let me go ahead and just minimize that for a moment. And here's the problem that we were just facing is why isn't NAT working with this scenario? If we do a show access list, here's our access list. We have access list 1 with sequence 10, line 10, permit 10.0.0.0. What is that? I mean, what is this permitting? What is this matching on? This is the exact match of 10.0.0.0. So the standard access list is kind of wacky, but you can actually use a wildcard mask. You can use the keyword host. You can also just put this in and it assumes, oh, you want to match on that 32-bit address. Well, guess what? We don't have any clients with that IP address. Not one. Nobody's going to have a host address with all zeros at the end of it. So the access list is not matching. And if we went back to my client here, all right, if we did an ifconfig 10.1.0.51, and what was I looking at? Oh yeah, see how that's not going to match the access control list of 10.0.0.0. So that's the problem. We can also do this. We can do a show IP NAT translations, and that's handy. And look, hey, there's a translation we have right there, but that's not for this client. That's from this static translation here from our config. So it's not matching this client. So what we need to do is fix the ACL. So config T, access list, this one. I'll just add another line to it. Permit 10, and then we'll just say 10 anything. And then we're going to check our work. Do show access list, and do show IP NAT translations, and show IP NAT statistics. So because I'm in configuration mode, I need to add a do in front of that. Otherwise, it's not going to like it. All right. So here it's showing that we are now using access list 1. And if we do a do show access list, see how I have no matches on any of this? So now let's generate some traffic from the client. We'll go back to a browser. And I'll go to cisco.com. Let's hope it works. Otherwise, it turns into a troubleshooting scenario. Let's go back here and just do a quick check while that's thinking about live show IP NAT translations. So we have a static. We don't have a dynamic yet. Look at that. Let me go to a command prompt and just, maybe it's just my browser. Oh, destination not, look at that. Okay, let's troubleshoot this. Let's troubleshoot this right now. Dynamic NAT isn't working. What likely needs to be corrected? We corrected the access control list, but it's still not flying. Let's actually continue that discussion real quick. And let's take a look. Okay, so 10, anything should match. I'm going to do this. No access list 1. Access list 1. Permit. And then I'm going to go to the interface gig 0/2. All right. There is IP NAT outside. I could take off NAT, put it back on, or I could just shut the interface, bring it back up. I'm going to just do this. No IP NAT outside, and IP NAT outside, and shut, no shut. That's overkill, but that should do it. And then we'll take a look at our config, troubleshooting NAT. Also, we had a chance to see all the commands for it again. All right, the other thing too is I want to make sure my router can get out to the internet. Show IP route. Oh, okay. It's a DHCP client. Let me give it a moment. Because if my router can't get to the internet, I'm not going to be able to, forward traffic through that device. Let's just show IP route. All right, so we got an IP address via DHCP. We also got a default route via DHCP. There's the administrative distance of 254 associated with the DHCP assigned default route. And let's do a ping to 8888. That works. Now, this is really important. If I do a show IP interface brief, no, that's not going to fly. No pressure, Keith. If we do a show IP interface brief, if I want to verify NAT's working, I could source the ping from 10.1.0.1 on the local router, and that would force translation if my translation rules are correct. And that way you can test it right from the router without having to go to a PC. So let's do a ping to Google, and we'll do a source and that local address. All right, that works. So if we do a show IP NAT translations, there's our translation it dynamically created for that ping request. So what's with this client? All right, let's check. Let's see if I can ping the router. Ping 10.1.0.1. Oh, there's your problem right there. Okay, so this client cannot get to its default gateway, can't get to the router. And, all right, I'm going to give this to you guys as far as a choice. In the chat, if you would like to see the conclusion of this troubleshooting right now, let's say troubleshoot. If you don't, say move on, and we'll go to the next quiz question, because I'm really curious about why the heck that's not working, and I'm game. All right, Ryan. All right. Yeah, I hear you, my friends. Let's do it. We're going to troubleshoot this bad boy. So let me bring up the switch. Let me show you the topology too. So there's the topology. So we're at this device right here, PC1 at 10.1.10.51. And that's going to verify. So it's in like VLAN 10, and it should be using the multilayer switch as the default gateway. Let's just bring up the multilayer switch. That's short for unassigned, by the way, just so you know. Okay, so we have VLAN 10, 10.1.10.254. Let's see if we can ping 10.1.10.51. Oh. So from this multilayer switch right here, we cannot ping that PC. So I will check the ports on that. Show interface status. Gig 0/1 is in VLAN 10. That's interface 10, 10.1.10.254. And I also want to make sure I can ping ourselves. 10.1.10. I can't ping myself. The plot thickens. Let's do a quick check real quick. Show IP route. Oh. All of my SVIs are down, I think. Holy schnikers. Show IP interface brief. This is great. Yeah, all my VLAN interfaces are down. Why are they down? Hold on a second. Show VLAN brief. I have the VLANs. I have access ports associated with those VLANs. All right, let's fix that. Interface VLAN 10. That's the layer 3 interface supporting VLAN 10. No shut. Interface VLAN 20. No shut. I don't see it popping up though. Something else is wrong. Something is wrong. VLAN 11 is between the multilayer switch and the router. And yeah, they're not coming up. Why is that? Show IP interface brief. Yeah, it's not administratively down. It's just down. Let me bounce an interface. Let's go do that real quick. Okay, it just said it came up. Oh yeah, I don't know what the heck was going on, but I'm going to bounce all of them. Shut, no shut. Oh, yeah, we got neighborships. Oh, yeah. I don't know why. Sometimes that happens. Let's do a show IP interface brief. And there we go. They are up. And I have a neighborship now. I have a neighborship between the multilayer switch and the router. That implies that that connection is working. Let's go back to our ping. This is pinging PC. There we go. So yeah, my interfaces were down, and I don't know why. They were not administratively down, but sometimes the concept of, did you turn it off and turn it back on again? That's what we just did. All right, so now let's go to this PC. Now, so we let's click on try again. Yeah, there's Cisco.com. It's coming. All right, so then check this out. If we do a show, and thanks, by the way, for all the help and support and encouragement. Like, do it, troubleshoot it. Show IP NAT translations. And before I press enter here, I just went to one site. That's what we're seeing here, Cisco.com. I'd like a guess. If you would chat in, let me know a guess. How many translations? Like, I know we have the IP address translation in place, but how many individual lines do you think we're going to see from a show IP NAT translations. Something between 1 and 10, 11 and 20, 20 to 30, or more than 30. And I'm just going to do one refresh here just to make sure that my translations haven't timed out. All right, you ready? Here we go. Your guesses are in. Nothing, because we're on the switch. Let's go to the router. Oh, it had some tracebacks. That's okay. All right, you ready for this? That's page 1. Here we go. Spacebar. That's page 2. Spacebar. That's page 3. Spacebar. So anybody who said more than 40, you're right on the money. Spacebar. And all we did was go to Cisco.com, but there's a lot of components and pieces that when we went to that site, it was asking our browser to collect and gather and all these sessions that were set up. We have a lot of DNS that was going on. That's the 888s to UDP port 53, and a lot of TLS sessions too with port 443 with HTTPS. Yeah, it's just going and going and going. So those are space bars I'm pressing. It's just a lot of output. All right, so happy translations. Thank you very much, Cisco environment, for making all that work for us. Thank you, Eve and Chief, for giving me a convenient place to practice that. And if we go back to the media, the problem with this was the access control list, because it was pointing to 10.0.0.0 exactly, and no clients would ever match that. But gives a great opportunity to practice. I want everybody to give yourself a big round of applause for, first of all, tackling that, and also for those people who said there's probably going to be more than 40, like Carlos, for the translations. Way to go. And one of the best ways to predict the behavior and troubleshoot like we just did is hands-on practice. So thanks for joining me in my own little hands-on practice here as we troubleshot why NAT wasn't working. The key is, I guess, routing first. Make sure basic routing works, and then you can take a look at other services like IPsec and NAT and QoS and all that good stuff. All right, moving on. I think that was question 3. Fantastic. Question 4 of 9. Which addresses could be used for NAT/PAT translation on R1's gig 0/2? All right. Wow. 58 of you on the right answer. So encouraging. That's fantastic. Let's talk about why that is. And this question here, here's how I would approach it. I would think, well, if this guy is going to use NAT, I'm assuming we're NATing from the inside of our network here going out to the internet, and it's supposed to be outside and this would be in. If we do source NAT, we change the source address to something here, the rest of the internet or our internal network needs to be able to route back to that address. So if this interface right here is using 23.1.2.25, let's take that mask in the 4th octet. Come see me for Subnet Saturdays. The 4th octet, 128, 64, 32, 16, 8, 4, 2, 1. And if we're using a 29-bit mask, this is 25, 26, 27, 28, 29. There's the new dividing line. Network on the left, host on the right. There's our block size. So our subnets are going to be subnet with a 0 in that last octet, 8. And you just keep adding the block size, 16, 24, 30, 60, 32, 48. I'm sorry, 8, 9, 10. I was going 16 there. Hold on a second. 24 plus 8 is 32. 32 plus 8 is 40. I think I got that right. So the ranges here would be .1 through 6 for valid host addresses, and 9 through 14, and 17 through 22, because 23 would be the broadcast. And then this would be 25 through 30, like that. And then, so those are the ranges. So if this is the IP address, our pools or overload or whatever we're doing, we need to be in that same subnet so the rest of the network's going to route back to us. You can't just use any address you want. You have to have an address that's going to be routable back to you. So in this case, because this interface is at 25, this is our subnet. And so any IP addresses from 25 to 30, and we're already using 25, that would be the right answer, and that's why. This is really a routing question. If you're translating to an IP address, the rest of the world needs to think or believe that they should route back to you, Mr. NAT Router. Question 5 of 9, double points. Based on this output, what is true? Okay, source NAT is in use is the right answer. How do we determine that? This column right here, inside local, are the real addresses that are used by clients. We've got one client at .51 on the 10 subnet and one client at .52 on the 20 subnet. Great. So we have two PCs at those addresses. And then as they get translated with source address translation, here are their new addresses as they appear to the outside world after NAT has happened. It looks like .51 is always being translated to .173, and it looks like .52 is always being translated to 172. We're not using we're not using overload, we're not using PAT, because each of these devices has their own IP address. So they don't have to share. And that's what this output is showing us. Also, as a heads up, and this may be worth a few points as well, when you see an entry like this, like an entry like this, that's just there without a protocol and without any ports, just that represents a one-to-one mapping. It could be dynamically set up as a one-to-one mapping from a pool with one-to-one, or it could be static mapping. We don't know based on this, like how it was implemented with dynamic or static, but it's NAT because we have that entry right there. And then above that, we've got the entries, the dynamic the translations that are currently in use by that system. Yep, and when we do PAT, it is referred to as overload because we're overloading one address. All right, question 6 of 9. Which ACL entry could potentially have been used as part of our NAT rules based on this output? So if these are the inside real IP addresses that are, and here's some ports as well, but the IP addresses on the inside hosts, which we've talked about a few times now, the access control list that's being used as part of the NAT rule is going to have to include those. So the common parts here are 10.1, and then everything in the third and fourth octet are unique. So what we'd have, an access control list would be permit 10.1.0.0, 0.0.255.255. That would work. Or we could also use 10.0.0.0 and then 0.255, 255, 255. That would also work. You could also say permit everything, but then you're too wide open. You're willing to translate anything that comes along, which is not ideal for a controlled environment. Source NAT/PAT. What does it translate exactly on the initial flow of traffic? All right, it translates on the source IP. That's why it's called source NAT. On the initial flow of traffic, translating the source IP address. And if we're using destination NAT, it would be the destination address on the initial flow of traffic, depending on how we set it up. So CCNA is going to focus on source NAT and source PAT only. Right after this live session, we'll take a few moments to do some Q&A, and then I'm going to make this video, the recorded video, private, so it's no longer viewable, and then I'll spend like an hour editing, tightening it up so it's really concise and short review, and that will go in the playlist. And so going forward, if you're here for the live event, fantastic, great, glad you're here, and then post, you can go ahead and get the abbreviated version to make the most of our time. Question 8 of 9, what command generated this output? All right, it is indeed show IP NAT statistics. That's a great one. Just to quickly verify what interfaces are enabled for inside or outside. Looks like I got a little tunnel interface there for fun. And then the pool, and then also how many translations are currently all set up. 1 static, 4 dynamic in this output. And here's the final question. It is double points. And the question is this: what is needed for this broken NAT/PAT configuration to work? It's not working. Why not? Let's talk about a strategy for taking the Cisco exam, by the way. Not all the questions are we going to get correct. And I go in with that attitude, whether it's an NP or an IE level written exam. I just realized that there's going to be a few questions that I don't know the answer to. I don't understand the wording, whatever. But it has to be the minority. So if you go in and you're really prepared and you've studied and labbed it up and you know most of the content, if you get a couple of questions that are like sideways or I don't get that, doesn't matter. Doesn't matter. You just smile and say, that's a great question. I have no idea. And then move on. But if you understand most of the blueprint and you practiced it, you can get several crazy questions and that you aren't comfortable with and still pass it with flying colors. All right, so let's talk about why the correct answer to this is use the correct outside IP address. What the heck is going on with this? So this ACL here looks great as far as permitting 10 anything and the clients up there to be translated. IPNet inside source list 1, matching on that ACL, go ahead and use the IP address on interface gig02 and the keyword overload. So that says whatever the IP address is right here, go ahead and use that. And then it says interface gig 0/3 is the inside, so this is the inside. And this says interface gig 01 is the outside. So the problem is, let's imagine this address is on this interface 14.10.10.10, something, whatever that IP address is. Basically, if traffic is routed from an inside to outside interface like this, like coming from a user going out here, for the translated address, we're using this IP address on that interface, gig 14, 14.10. That doesn't make any sense, but we'll try to do it. So we're going to swap out the user's source address with 14.10.10.10 as we send the packet this way. I'll tell you what, very unlikely that the reply traffic for 14.10.10 is coming back this way, especially if that address is reachable on the other interface. So the key here is that if we're going to use interface gig whatever overload, it really should be pointing to our outside IP address for that overload. So in this case, if we change this to a 1 here and said interface gig 01 overload, then we'd be overloading on this address here, 15.111, and we'd be great because the router has the address, it's reachable. So whatever interface we're using for the outside interface should be the interface IP address we're pulling from for the NAT. So that's it for this quiz, this recorded version and the edited version. Thanks for joining me. If you want to participate in the live quizzes, we have them every single Sunday Pacific time at 11 a.m. I'd love to have you there. Meanwhile, have a great day, and we'll catch you in the next live event.